Yeah, very good evening to all. So, good evening, Sri Lanka, Lakshmi, Mickey, Samrin, Shaikh, Samrin, so Arundhati. So, very good evening to all. Thank you for joining. Thank you for your presence in this 21-day masterclass. So, today is day 8. So, today we are gonna see timing regions in Verilog. So, very good evening to all. Thank you for joining. Kalyani. So, Sri Krishna. So, very good evening to all. So, let's wait for a few minutes. So, remaining people are also have to join. So, let's wait for them. So, and then we will start our session. So, today is day 8. So, Pranav, good evening, sir. So, Srinivasa Murthy, so good evening. So, good evening to sir. So, let's wait for a few minutes. So, there are 39 people only. So, we wait for remaining people have to join. So, yeah, if you take any hardware language, system Verilog, both language having the separate timing regions to execute the code. So, based on these timing regions only, our code will be executed. So, let's see in this session how it's executed, and then we are also see non-blocking and blocking assignments today in this session. So, what is difference between blocking and non-blocking assignments? How it is executed? So, we'll try to write a code on both blocking and non-blocking assignments. So, we'll see in this session. So, let's start the session. So, today we're gonna see timing regions in Verilog. So, thank you guys. Thank you for joining. So, very good evening to all. So, these are the regions we have in the Verilog. So, like a preponed region, active region, inactive region, NBA, non-blocking region, and then postponed regions. So, these are the regions we have in the Verilog. So, our Verilog code will be executed based on this region. Firstly, it will execute the preponed region statements, and then it will execute the active region statements. So, and then it will move to inactive region statements. So, and then it will execute the NBA region statements, and then finally it will execute postponed region statements. So, let's see what are the preponed region statements, active region statements. So, what is the preponed, what is active, how it is works, so what is the functionalities of these regions. Let's see in the session. So, we'll see. So, yeah, in the active region, so in the active region, it will perform the initial stage of continuous assignment, blocking assignments, and primitives, and then module process statements. So, it will execute the module process statements. It means it will perform the initial stage of our code. So, if any code there is a so there is a need for, so there is the initial signals, like if you want to run the RTL code, you have to declare the signals. So, you have to make a data type, you have to register the signals. So, this registration or this initial stage process of execution is taken by active region. So, it will execute the module process statements, and also it will evaluate the continuous assignment and the primitives. So, the blocking assignments are performed in, so there are two kinds of assignments we have, like a blocking and a non-blocking. So, we'll see in this session what is difference between both of them. So, the blocking assignments are executed in inactive region. So, if you take in dollar display, so dollar display and the dollar display is performed in active region. If you use the dollar display in your code, it will be performed or executed in active region only. Based on the active region only, it will display our outputs in our transcript. So in the coming to the inactive region, it will come after the active region. So it some active region will do the LHS if you have some condition like having arithmetic operation in RHS right hand side. So this RHS is performed in the active region. So if you add any delay in the RHS, it is take care by it is comes under the inactive region. So if you adding delay, so delay is performed by the inactive region. So if you take so we mostly use the assignments like there is a necessity to use assignments. So LHS equal to RHS, RHS plus LHS. So RHS is performed in, so right hand side what you have written logic like if you taken example of A equal to B plus C, so the B plus C is executed in active region. So if you add delay in the condition, so in your statements, it will be taken, it will be executed in inactive region. So this is the delay performed in inactive region. So okay, thank you guys, thank you for joining. Very good evening to all. So this is the, so we have the regions like inactive, active region, inactive region, NBA region, monitor in our Verilog timing regions. So this is our today's topic. So in the active region, it will perform the RHS and it will perform the display, dollar display, and then basic initial process of our Verilog code like making like initializing the variables, and then performing the RHS, and then dollar display are performed in active region. In the inactive region, it will do the, if you add any, if you do, it will perform the delay process. So if you add any delay in your circuit, in your condition, it will do that only. So it will do the delay operation in the inactive region. So non-blocking regions, so non-blocking, in the non-blocking region, it will perform the non-blocking assignments. So in the active region, it will do the blocking. So we have two assignments, blocking assignments, non-blocking assignments. So the blocking assignments will performed in active region. In the non-blocking, so you can see non-blocking assignments in this region, it will do the non-blocking assignments. It is based on, so we know that RHS, if using the non-blocking assignments, the RHS is performed or executed or computed in the active region, but it won't assign the RHS to LHS. It will wait for NBA region. So if your code comes in the NBA region only, if it is in NBA region, then only it will assign the RHS to LHS if you are using non-blocking assignments. Or else if you are using the very simple blocking assignment, means it will immediately assign the RHS to LHS in the active region itself. So if you are using the non-blocking assignments, your RHS will be computed, executed in the active region, and then it will assign to the LHS in the non-blocking region. So non-blocking assignment, NBA region. So this is the regions, this is the rule we have to, the Verilog code is taken. So take out. So and then monitor. So monitors comes under the postpone region. So it will perform the dollar monitor. These are the like system tasks like a dollar monitor, dollar display, dollar stop. This system tasks are performed in the postpone region or monitor region. So in the active region, it will do active dollar display, and then performing LHS. If you are using the blocking assignment, it will assigning to RHS to LHS in the active region. In the inactive region, it will do the delay process. In the NBA region, it will do the assigning the, so we have in the NBA region, if you are using the non-blocking assignments, the RHS already as computed in the active region. In the NBA, from this NBA region only, it will assign to the LHS. So this is the main thing in NBA, like a non-blocking assignment. So and then monitor, it will comes under the postpone region. So it will do the dollar monitor. So dollar monitor means it will works if any changes in our signals, it will capture the output and then it will give an output. So based on that, so if anything changes, so this monitor, so this postpone region will works after the three regions have to complete it. So it has to complete it. So active region, inactive region, non-blocking regions. So these three regions have to complete it, and then it will that postpone region will work. So it will move to the postpone region. So firstly it will start with active region, and then it will move to inactive region, and then non-blocking, and then postpone region. This is the timing regions our Verilog code is performing or using. So based on these regions only it will execute the code. So let's move to the what is the active region. So active events. So active events occur at this current simulation time, and can be processed in any order. So you can see here LHS. So it will do the computation process of RHS for the non-blocking assignment. So and then input and update the output Verilog primitives. So it will if you using a blocking assignment, I already said no. It will in the active region it will performing assigning the RHS and the LHS. So RHS to LHS if you are using the blocking assignments in the active region. So computation of the RHS. So left hand side computation is take over by the active region. So if you are using the blocking means it will immediately assign to LHS. If you are using the non-blocking assignments, so it will update it at the NBA region. So and then this is the active region. So you can see blocking assignments of all modules. It will perform blocking assignments of all modules, continuous assignments of all modules, $finish, $display. These commands are performed in the active region. So this is the active region in the Verilog timing regions. So and then we move to inactive region. So inactive regions, inactive events occur at the current simulation time and shall be processed after processing all active elements. So it will wait for the active region have to complete the all execution in the active region, and then if there is any add delay means it will execute in the inactive region. So an explicit delay is scheduled in the inactive region of current time slot. So in the inactive for the from the current time slot it will do the scheduled delay. If you any added or any if you did any scheduled delay means it will executed in the inactive region. So this is this is the process of inactive region in Verilog or timing regions. So and then we'll move to the NBA events. It's known as NBA region. So non-blocking assignments. So non-blocking I already said no. So if for non-blocking assignments the RHS is already computed in the active region, it just assigning the RHS to LHS in the NBA regions. So this NBA region have to wait for active region have to complete, and then inactive region have to complete. So NBA is wait for two regions, active and inactive region. Then only it can perform the assigning the RHS to LHS. So this is the NBA regions. So and then we'll move to the monitor event. So it is a postponed region. I already said no. The monitor region have to wait for complete the active region, inactive region, NBA region. Then only it will work. It will perform. So and then the $monitor, $stop. These are the system tasks are executed as a part of a monitor region in the like a postponed region. So this is the regions we have in the Verilog: active, inactive, postponed, NB and postponed. So So this is a very important thing you have to know about Verilog region timing. So based on this only you can understand how code is executed. So let's see a difference between non-blocking and blocking assignments. So we have the two assignments, blocking and non-blocking. So blocking means this symbol. So if you are using one equal sign is known as blocking assignments. If you are user like this symbol is denoted to non-blocking, like a less than equal. So this symbol is denoted to non-blocking. So execution. So the execution of the blocking assignment is in sequential manner. So the execution of the non-blocking in the concurrent or simultaneous. So usage of the blocking means combinational circuits and the test benches. So why we use the blocking assignments for combinational means, so in the combinational circuit we didn't have any trigger element. So trigger element means if you take a sequential means you have the clock, like a passage of clock and a cage of clock. Based on the clock only it will move to next state. We can work on it will work based on the clock pulses. But in the combinational circuits we didn't have any triggering elements. So we have to perform RHS, and then we have to immediately assign to the LHS. So there is necessary to assign the RHS to LHS in the combinational circuit. So that's why blocking assignments are used in the mostly we have to use mostly in the combinational logic. So we can use non-blocking assignments in the flip-flops, like in the sequential circuits. Why? Because of, so if you're in the sequential circuits, if you're using the blocking assignment means there's a chance to you may get a race around condition. So to reduce the race around condition, we can use a non-blocking assignments. Why? Because of we can reduce the conflict of the execution signals. So if you are using a non-blocking assignments, it is based on the clock, like a sequential circuit. So it will so in the it is the RHS is if you have to say, if you once in the first clock cycle it will perform the RHS. In the second clock cycle, if you are using the sequential means, if in the second clock cycle it will do the inactive operations. In the third clock cycle it will do the NBA operation, so NBA region operation. So it need 3 clock cycle to get the NBA, like a unblocking assignment output. So by using this we can reduce the race around condition. So we can control the race around condition if you are using the non-blocking assignment in the sequential circuits. So this is the main thing. So and then simulation time, the blocks time progression, and it is also, so you can see that blocking assignments blocks time progression, and it in the non-blocking means it allows the time progression. So and then dependency handling, value update immediately. We know that the values are updated immediately. So old values are used to until the next time setup. So we know that old values have to assign to LHS in the NBA region only. So it have to wait. So best practice, use always for combinational logic. So this you know that this always at star means if any signal in the our port list triggered means change 0 to 1. So we are passing our inputs from test bench to design code. So if I am passing the stimulus means it will works like a triggering only. So if you are using the combinational circuits, you can use this way. It is a very good way to writing the blocking assignments, and also it is easy only. If you are using the initial begin block in our design code of the combination logic, so there is no triggering element. So there is a chance to get unstable or maybe maybe your output will be like what to say, output will be changed based on our inputs. So if you are using the triggering like this means if any one signals in our any one of the signals in our port list as changed or triggered means it will execute the always block. But there is no triggering event in the initial begin block. So this is a best way to write the blocking assignments in the combination logic. So we know that always passage of clock it is for the sequential circuits. So these are the difference we have. So in the block, this is a difference of a blocking and the non-blocking assignments. So basically we have to take into mind symbol. 1 equals n means it's a blocking, so less than equal means it's non-blocking. So values are update immediately in the blocking assignments. So values are have to wait for NBA region to apply the LHS to RHS, sorry RH to LSS in the non-blocking assignments. So and then this is another thing. So best practice of the writing combination logic means use the always star. So it won't wait for initial beacon. If any one of signal is triggered means it will start execution. So based on the passage clock it will execute our non-blocking assignments. So these are difference. So these are the logic events we have. So these are regions we have: active, inactive, NBA, and then monitor. So then guys, if you guys are really interested, you can convert this in masterclass, 21-day masterclass into 1 month internship on FPGA. So you will get the benefits of uh, these things like all 30 days recording session, all 30 days presentation, exclusive project code, and you can download also. So and you will get the VIP community group for your doubt clearing, and then you will get the internship confirmation letter from IETE, and you will get the 90 days LMS course access. So we have the LMS access. So in that we have the recorded sessions all 30 days. So you can access up to 90 days. So and then you will get the assignments and the tasks, and then we are conducting also weekly live session. So you will get the resume building idea and mock test. So we are providing the internship certificate and also participation certificate. This all comes under the discounted fee of just 999. So our regular fee is 3999. So in this time we are providing our course 1 month internship program at the discounted fee of just 999. So if you want to means if you guys are really interested, you can get by using this registration link, and also our organizer will post the link on chat box, command box. So this is limited time period. This offer will close at the 22 March. So I hope you are registering. So let's move to coding part. So we'll try to write the code for what is we have it. We'll try to write a difference to know the difference between the NBA and non-blocking assignments, like a blocking and non-blocking assignments in the EDA playground. So we'll try to write code for that. So and think so for that I'm going to use EDA playground. Yeah, so firstly I'm going to write how NBA like a blocking assignment will works. So let's see. So firstly I choose my simulator. My simulator will choose the I will choose Siemens Custard for my simulation. So I just run my code module. So blocking assignment like a BA. So and then end module. I didn't write any port list here. Why? Because of I just want to run this like a simulation without a port list. So I didn't write any logic for circuit. So for that I'm just write only module name only. So and then I'm registering some variable like integer a, b, and c. So I register my integer, 3 integer like a b c, each and every integer like a having the 32-bit wide. So it is a default size of the integer is 32-bit. So and then initial begin and so initial begin end. So I'm going to use blocking. So before going to that, I want to share one thing. So this one equal sign is refers to blocking assignment. And this symbol is refers to less than equal refers to non-blocking assignment. Non-blocking assignment. So this is that. So I'm going to use blocking assignment here, like a equal to 10. So I just assign some value for a, and then b equal to 20, and then c equal to b. So I just pass my b, whatever. So what value of the b it having means it will just assigning to c. So and then I use dollar display here. These whole things are executed in the active region. So non-blocking is executed. It's executed in active region. It is executed in NBA. Non-blocking assignment is executed in NBA region. So I just write dollar display. So dollar display is also executed in active region. So just write dollar display. So in the dollar display, just want to see my output in binary. So a equal binary. So decimal. So I just choose decimal here, b also decimal, then c also decimal. So a comma b comma c. So I just run save and run this, so to see my output. So what I am getting. Yeah, you can see here my a having the a equal 20, b equal 20, c equal 20, and then so y you can see I'm getting space here, so lot of gap. I means we know that integer default size is 32-bit. So to reduce that unwanted gap means I just add 0 here in decimal in the display statement. It will give the only decimal values without space. So I just run this again. So you can see here a equal 20, b equal 20, c equal 20. So I'm getting correct. If so, here I'm going to use instead of dollar display, I'm going to use dollar monitor here. Let's see what happened. So dollar monitor is executed in dollar monitor. So dollar monitor is executed in postpone region. So postpone region means it will execute lastly. So let's see what happens. So you can see I'm getting the same output. Why? Because of firstly it will execute the active region, and it will execute the inactive region, and then NBA region, and then it will move to the postpone region. So and also in before I am using dollar display, same thing it will happen. Why? Because of in the active region, if you are using the blocking assignment, it will automatically or else it will do immediately assigning the RHS to LHS in the active region. So same thing I'm going to change here, dollar display. I am writing here non-blocking, so this is non-blocking assignment symbol. So I just used the dollar display to see my output. So and this is a non-blocking assignment. So you can see if I'm using this kind of like a symbol, this is a non-blocking assignment symbol. So I just written that. If I run wins, let's see what happen. So I need to know the timing. If internship training, they only is it. So timing means, so we have the LMS access. So I have received some query here, Rajalashmi Kumari. So it means we have the LMS. So this is like a online cloud access. So on that access there are all 30 days recording sessions we have. So from in this 21 day YouTube, it is in your free in cost. So on remaining 9 days, and we have do some project codes. So we add in the our LMS access. So you will get the 90 days like access for LMS. So from the LMS, it having the 30 days recording sessions. So each and every day, all that is recording session with the projects and the PPTs you will get in the internship program. So you will get the online LMS course access. It's just like a video watching. So you have the video recording sessions. So and then we'll move to our output. So I just changed in my assignments like a non-blocking, but I am using the display statements. The display statements will it works in the active region. It works in the non-blocking region. So you can see here. So just run this. You can see here. I am getting 0 here now. So I am using the non-blocking, and then I am using the dollar display. So dollar display will work on in the active region. So it will check in the active region. So what are the values in my variable it having. So it will check it will check the variables values, and but I am using the non-blocking here. So it will execute. So this 10, 20 and then B value, these values are executed in the NBA region. So in the active region itself, it having the A equals 0, B equals 0, C equals 0 only it having. So this is default value in the it having. So these values are updated in the NP region, but I'm using dollar display to display my output. But this display is performed in active region and the time in the active region. So my variables didn't have any values, it didn't get updated, so that it is showing 0 here. So for default it having 0 only. So I just received that output only. So you can see A equals 0, B equals 0, C equals 0. So if I'm using dollar monitor here, so I will get the correct correct output. You can see here 20, 10, A equal to 10, B equal to 20, C equal to 0. So you can see here I am assigning the B equal to I am assigning the B to C. So I am just assigning the whatever it having the B value, I just assigning to C. But here you can see I didn't get C output. It's just showing the 0 output. Why? Because of the monitor will work after completion of the all 3 regions, like inactive region, active region, NBA region. After that only the monitor will execute, and then it will display my our output. But at the current time it will perform only one current simulation time, like a current time only, one time only, like a one current simulation time. It will execute it like a LHS RHS will be executed to assign it to the LHS. So at the current simulation time, so at the time, at the time 10 will be assigned to the A, 20 will be assigned to the B. At the time that the B, it won't update it. Why? Because of it need additional delay to update the B value, so RHS value. Here you can see these all things are updated, it having values directly, but it need the help of previous one operation, like a previous assignment. So it won't update the value. It's for this updation, so for this B update, we need to give some delay here, then only it will update. So if I give the delay means, like I just given some delay here, just save and run this again to update my B value. So you can see here I got some SQL 20. So 20 means B, I'm assigning 20 for B, so I just assigning to C, same value. So at the current simulation time, these are executed, these RHS will assign to the LHS in the current simulation time. But here I didn't give value for C, I just give B here to assign the C, but B have to get update. But in the one single, like a one current simulation time, it won't get update, so we have to give delay. So after some delay, it can be update. So this is a reason. So this delay operation performed in the inactive region. So this is a usage of the timing analysis or region analysis. So this is the how our Verilog code will be executed based on our blocking and non-blocking, and then dollar monitor, dollar display, delay, how it is executed in the according to the regions. So and then we'll try to write the always block. So always block needs some triggering element. So triggering event, I just use passage of my clock. So I return here clock, so I have to register here. So if I register in the port list, I will get an error. Why? Because of, so the port list will get a stimulus from the other module only. So we can't we can't pass a stimulus inside the same module. So we can get this module will get the stimulus from the other module only. We can't give the stimulus from the current module. So I just registered like a registered clock. So this it works like a variable only. So I want to generate the clock pulses, triggering element. So for that I'm write always at every 5 nanosecond my clock will be toggle, or else I will show another thing in the initial. Begin. I'm using the another initial begin block, initial begin. So in that just give some value for clock, a clock equals 0. So I just use my repeat. So repeat is one keyword here. Repeat. So inside that, if I give 10 means it will repeat up to 10 times. So just give 5 here. It will repeat means, so if I repeat like a begin end, so this is a repeat block. If I use this way like a repeat, and then how many times repeat, and then begin. And this means it's like initial begin block only, so you can call this repeat block. So but now I'm going to use directly only clock triggering, so clock toggling. So at every 5 nanosecond my clock will toggle. So this is the toggling method. So I just assigning the knot of a complement of a clock. So I'm currently so firstly we can just remove the non-blocking. I just give the blocking only. So in the display also dollar display, these all things are performed in the active region. So I just removed my delay here. So let's see what happened. So and then simulation time. So I just know my time. So I just add time, like time equal to decimal. Yeah. I just add my timing. So time, so it will, I can see my time execution simulation time here. So you can see here. So I just add 0 here, then only I can reduce the space in the transcript. So in the first nanosecond I'm getting the value of A equal 10, B equal 20, C equal 20. 15th in the 15th nanoseconds I'm getting value like a same value. So and then if I change dollar monitor here, let's see what happened. So dollar monitor will executed on the postponed region. So on that, what will happen? Sorry, I just use instead of dollar monitor display only, but in the change in assignments. So non-blocking assignments. I'm using non-blocking assignments here. So I'm using non-blocking and I'm using a display statement dollar display. Let's see what happened. Yeah, you can see here it will update. So values are updated by each clock pulses. So this is the difference. If you are using the combination logic, it won't update. So if you are using the non-blocking, if you are using the display means it won't update. So it will show only one output. But if you are using the sequential logic based on the clock, it will execute based on our clock. So in the first clock pulse, my values are 0 only. So in the second clock pulse, I got some A and B value output, A equal 10, B equal 20. So in the third clock cycle, I got output like A equal 10, B equal 20, C equal 20. So in this I used to repeat here. So it means it will do 5 clock cycles. So in the if you are using the always block based on our clock pulses, it will automatically executed or updated by one based on the clock pulses. So based on the clock pulses, it will automatically update the values. So first clock pulses, it didn't have any value. You can see I am using the non-blocking here, but I am using the dollar display. So it will execute in the active region. It will execute in the active region. At the first clock cycle in the active region, it won't see any values. So on the same clock pulse, it will move to the inactive region, and it will move to the NB, and it will move to the postponed region in the one clock cycle, one clock pulse. So so from that one clock pulse, so in the NBA region, so in the first clock pulse in the NBA region, that LHS RHS will assign to the LHS in the NBA region in the first clock cycle, and then it will, if you move to second cycle, so I'm getting like output like so in the second cycle I'm using the dollar display. It will perform in the active region, so we have the value A and B, 10 and 20, so it printed here. So and then in the second cycle, so B is updated by the 20, so B is updated by 20, and then it will update it to C in the in the coming next cycle. So in the third clock cycle, at the active active region, A having a 10 value, B having 10 value, 20 value, so C also having a 20 value. So based on our execution, so this is the reason, if you are using the always block, is better way to writing blocking and non-blocking assignments. So this is a difference. So based on our always block and initial we can block blocking and non-blocking, so this is a difference. So if I add delay means, let's see what happens. If I add a delay in the this condition, in this statement, let's see what happened. So in the second cycle itself, it got updated. So you can see here, previously I'm getting the C value in this third cycle, but if I add some delay here, so it will perform in the inactive region, so I got updated in the second cycle itself. So this is the usage of the timing regions in Verilog. So it has two assignments, like blocking and non-blocking. So non-blocking will executed in the NBA region, so blocking will be executed in the active region. So this is the main thing you have to know in the Verilog, how it is executed. So and then dollar monitor will execute in postpone, dollar display will executed on the active region. So dollar finish also executed in the active region. So this is for today. So if you just try these examples at your home, so then only if you write some code by yourself only, you can understand the execution, the Verilog. So it will be helpful for your future in Verilog. So this is for today. So tomorrow we'll see the new topic. So thank you for listening. So thank you for patience and listening for this masterclass. So we'll see you tomorrow. Thank you guys. Thank you for listening.